Okay, we're still in section 10 of the notes, but the second part, and this is just a review of what you've done in Math 100. I will go to the whiteboard later, but you're going to be given a system, a 2x2 system. That's two equations, two unknowns. And what we're going to do is we're going to talk about the methods that were described to you in Math 100, and certainly we'll go through some examples. But I want to point out you should be very familiar with this topic. All right. So we'll talk about this, and I'll go to the whiteboard to do that. We do provide good images for you. The reason being is we want you to look at those good images. Most people are not capable of drawing really good images by hand, and we'll talk about that as we go through the problem set. We're also going to talk about the terminology that was discussed in Math 100, although you may not be able to remember that, but I will speak through that. All right. So let me go switch to the a new share, and I'm going to go to the whiteboard again. And again, we're going to talk through the problem set. All right. Now, when I say I'm talking through the problem set, I'm talking through an example that you should be somewhat familiar with from Math 100. So it says, we're hoping that you can recall from Math 100 that you did solve a linear system of equations, all right, in two unknowns, typically X and Y. So I'm going to write down the methods that you were presented in Math 100. And the way I'm going to do that, I'm going to talk about them one at a time. And we'll go back to notes in a second. So if you're given this problem over here, I'm going to say what I would tend to do in this problem over here is that I would do this thing by the method of elimination. Now, in Math 100, they called it elimination. Your teachers might have also called it addition. Some of your teachers might have called it Gaussian elimination. And what we do over here is if we're going to do elimination, I want to point out, typically what we like is certainly this is an absolute requirement, the equal signs line up because we're going to add things together. And you couldn't add things together unless they're equal. Like if you add this together, what you get? You get 7x plus y equals minus 11. Well, I got to be honest with you, that didn't happen. I mean, that happened. I got the addition, but I got no eliminations of the problem. So I'm going to erase that and indicate I don't think that was a good idea. And again, we're just reviewing what you did in Math 100. So again, I want to point out Math 100, they talked about, they might have called this elimination or they might have called this addition. Well, I just did add it together, but there was no eliminations. All right, let me point this out again. Absolutely, we have to add things together that are equal. Equal signs need to line up. They have to line up. All right. Now, why is that? If I were adding minus 16 to this side, I'd have to add minus 16 to this side. And I'm saying they're identical statements. All right. But what do we want? We want something to disappear. So what your teachers told you in Math 100 was to select something to disappear. And I'm going to select this one. So what we're really looking for is we're looking for the LCM between 3 and 2. And that would be 6. Right. So I need to make, the top equation, if I want to get rid of the y's, plus 6. Well, what times 3 would give you plus 6 is 2. And the bottom equation has to be minus 6. Well, what times minus 2 gives you minus 6? That would be 3. All right, let me go through that with you. I'm multiplying the top equation by 2. What does that mean? Both sides are being multiplied by 2. What do you get? 4x plus 6y equals 10. Again, I multiplied both sides by the number 2, fair and equal treatment. Then what do you get? 15x minus 6y is equal, well, 3 times minus 16 is minus 48. Then what are you going to do? Add them together. And this is called the addition method or the elimination method. What are you going to get? 19x. The y's disappear, and you get minus 38. Now, it's so typical that things work out nicely. It really is. It's very typical. Does life work out nicely? Not really. I hate to say this, algebra does work out nicely. What do you get over here? Minus 2. All right. So that wasn't bad. I know what the x is, but now I got to find out what the y is. You could use elimination again. Let me do that for you. I'm going to do elimination again. I'm going to erase this business over here. And what I'm going to eliminate now is I'm going to eliminate the x's. All right, so what's the LCM between 2 and 5? That's 10, right? So I'm going to say I have to multiply the top by 5 because 5 times 2 is 10. And I want to make the bottom 2 an addition. I want to make that the opposite. So I'm going to say minus 2. Let me go through that with you. And I'll do that over here. So if you multiply the top by 5, you get 10x plus 15y equals 25. Where you get the second equation, multiply by minus 2, minus 10x plus 4y equals, let's see, 32, right? A line reminds me of an addition. I'm going to add these things together, and we're hoping for an elimination, and the x's disappear. What do you get? 19y. And what does that give you? 57, right? And again, my claim is it's probably going to work out pretty nicely. The real world doesn't work out this way, by the way. Well, what times 19 would give you 57.3? All right. So I'm going to claim I think I know the answer now. So someone says, what do you mean you think you know the answer? I'm not sure. So I'm going to say my answer is an ordered pair of numbers, x is minus 2 and y is 3. But I want to check it. Now someone says, where do you check it? In the original statement. This is the original statement. Let's check it out. And what do you get? Well, I'm going to do the x first. That would be minus 4 minus 10. And then I'm going to do the y's. Plus 9. Again, I think y is 3, minus 6. Minus 4 plus 9 is 5. And minus 10 minus 6 minus 16. Does it check? Of course it checks. All right. So what do I know? I know x is minus 2. And I know y is 3. This is what's known as elimination or addition. Let me talk about the other method. All right. Go back over here. And I'm going to talk about the other method. The other method is what's known as substitution. There's nothing wrong with substitution. Substitution, what you need to do is you need to take one of these equations, and there's 2 of them, and solve it for either x or y. Well, I'm going to take this equation here, and I'm going to solve it for y. And I'll go through it in steps with you. What I'm going to do is I'm going to add 2y to both sides, and I'm going to add 16 to both sides. And what would you end up with? 5x plus 16 equals 2y. And then what would I do? I would divide both sides by 2. And again, this is what's known as substitution. Another method that was widely used in Math 100. And we're just reviewing what you've done in Math 100. So what do you go over here? 5x plus 16 over 2 equals y. Now here comes the tough part for a lot of students. They've got to take this thing, which sort of some students it's nightmarish, and plug it in up here. And let's go through that. And what are you going to get? You're going to get 2x plus 3y. Well, I believe y is 5x plus 16 over 2. And that equals 5. All right, let's keep going through it. And I'm looking at it. And what I'm going to do, which might seem strange to you, I'm going to multiply both sides by 2. So why are you doing that? To get rid of the denominator or the fraction of the problem. What do you get? 4x plus 3 times 5x plus 16. Again, the 2 canceled, equals 10. 4x plus 15x plus, well, 3 times 16 is going to be 48, equals 10. All right, let's keep going. 19x plus 48 is equal to 10. I'm going to subtract 48 from both sides. And yeah, it's a lot of work. I know that. What do you get over here? It's a technique you're going to use, though. And what do you get there? Minus 38, right? What do you do now? Divide both sides by 19. And lo and behold, a nice simple answer, minus 2. All right, now, so what do you do now? Well, I got to be honest with you. That was a lot of work for me. I'm just going to go back up here and plug it in. And what's y going to be equal to? I'll write it down for you. Y, and again, keep in mind that x is minus 2. Y, well, if x is minus 2, you get minus 10 plus 16 over 2. And what would that be? Minus 10 plus 16 is 6. And 6 divided by 2 is 3. So y is 2. I'm going to write that as an ordered pair of numbers. Minus 2 I'm sorry. I said, I have 2 on my brain. That's crazy. Let me erase that. 6 divided by 2 is not 2, it's 3. What am I saying? X is minus 2 and Y is 3. Could we check that? We can, but I want to claim we've already checked it. So I know it's true. Remember we did this before. Minus 2, 3. So we're getting the same answer. Not a surprise there. And I want to go to the third method. The third method is the first method they used in Math 100. I'm going to pull this on the side again. I'm going to talk about what they did in Math 100. All right. They did what's called a graphical technique. Sorry about that. And I'll talk about that. They talked about graphing. What's the problem with graphing? It's time consuming. It's generally not accurate. And if you're not good at drawing even a really kind of like a crabby picture, it's going to be really tough to read this thing. I'm going to graph one line at a time. I'm going to graph this one over here. 2x plus 3y is equal to 5. Now, if I were to do that, I'd have to come up with a table for it. Now, again, if you have a different technique, that's fine. You still need 2 points. I would say 1, 1 would be a really easy point on that curve. All right, I got that down. Someone says, is there another easy point? Well, I'm kind of looking at it and I kept playing around with the numbers. I like integers because integers are easy for me to plot. I would say probably 3 for y. Right, that would give me 9, right? And then I'd have to do minus 2 for x. All right, so let's put that down. So let's see, 1, 2, and then 3 up. All right, I'm going to draw my line through that. And I'll be honest with you, my lines never look good. All right, there's my line. Let's do the other line. And the other line is going to be 5x minus 2y equals minus 16. And I'll talk about it. And I'll talk about what you've done in Math 100. X and y. Well, looking at it, I'd probably say, the y, it's pretty easy. If I set x to be 0, what would you get over there? You'd get, minus 8. But I gotta be honest, I really don't like that too much. I'll tell you the number one reason I don't like that is the amount of counting involved for that. I'd have to count 8 units to get to that point. So I'm gonna look around for maybe something else. And I'm gonna say, maybe 3. All right, 3 for the y. And so why are you doing it? I think it's easy. If it's not easy, I won't do it though. You get 5x minus 6 equals minus 16. All right, I'm looking at that. Saying, what would that give me? Well, x would have to be minus 2, right? That's not so bad. All right. That someone says, could you do other numbers? And of course we could. And I want to do another number. I'm wondering what numbers to choose. Now, someone says, I want to choose y to be 0. Not a good idea because then x would be fraction. Let's take a look at it. And I don't know, I'm going to look at it and say, what's another nice number to use? I'm thinking, right? Now, the reason I want to point this out, I don't really think graphing is a good idea because there's so much thinking involved. Right? So much thinking involved for that. And I don't know. I'm going to say, I don't know. Let's see. Now I think I'm almost done thinking. Right? That's why graphing's so difficult. Let's plot the points down now. Now here my graph, same axes. Minus 2, 3. That's right here. And the other one's going to be 0, minus 8. And I got to put that down, right? That's a lot of counting. Way over there. Let me draw that line through now. And lo and behold, I found a point of intersection. It's right over here. What's the point of intersection? Point of intersection. It occurred when x was, let's put this in black, when x was minus 2 and the y was 3. Did we know that? Of course we did. How do we know that? The very first technique we used, the elimination addition method, led to that answer. Okay, so I certainly want to lead the witness over here, but what do you think what do you think, and you certainly have an opinion about it. What do you think the easiest technique is? I'm going to say elimination for me is the easiest technique. All right. The next thing I would probably go to substitution, but substitution can be very difficult. What's the worst technique? Again, this is my opinion. You don't have to share my opinions, but graphing it. It's just too much thinking involved. All right. Let's go back to the notes. And we're over here. I want to point out this is a much better graph. And I'm going to make sure you understand what I mean by that. I used the machine to do that. And I'll draw these lines in for you. Yeah, they did it for me. What line is this? Well, let's take a look at that. And that would be, well, you know what? I think I made a mistake in my graph. Let me go back over here. I just noticed it. My graph's not their graph, is it? Did I do something wrong here? Oh, I see now. I see now. I said y is -8. Y was actually +8. Sorry about that. What does that mean? It's like this. And I apologize for that. It's not the green line. All right. It's another reason why graphing's so bad. Bad line there. I got the point of intersection though. All right. And I apologize for that. So what's this line over here? Let's take a look at it. This line is 5x minus 2y equals -16. I want to point out this line in here intersects up at 8. All right. And this line over here, I'll put it in green for you, is going to be 2x plus 3y is equal to 5. And we have a point of intersections right over here. Can we read it from the graph? We can. If I looked at it, I want to put I'm looking at the x's, that's -2. And I'm looking at the y, it's 3. Is this accurate? It could be, but it may not be accurate. All right. How do we know it's accurate? We have to check it. So I'm sorry, -2. I did it again. My erase around. And again, we certainly, we know that to be true. We've already checked it when we did the elimination. We know it to be true. All right, so I'm going to say my favorite technique is elimination because it's so easy. Next one was substitution, but graphing is also incredibly important. What's the problem with graphing? Well, as you notice, I put a wrong graph down. I made a mistake. I made a mistake in computation. All right, let's talk about terminology though. And what's the problem with terminology? Well, words often get in the way of understanding. And I'm going to say you want to pay careful attention to this information over here. As you move forward in mathematics, it will be used, and it's used quite a lot when you're solving systems of linear equations. So this is for systems of linear equations, and they're going to fall into 3 categories. And we'll talk about those, what they mean. Consistent and independent, what it means exactly one solution. So if you look at this example over here, this is an example of a consistent and independent. All right, consistent and independent, exactly one solution. What we found? The point -2, 3. Inconsistent, a system with no solutions over here. Let me just outline what I mean by that. There will be no solution. Now, what does that mean as far as lines are concerned? It means I'd have 2 lines down that would never touch each other. So inconsistent means you have a line here and have another line where they would never, ever touch each other. They have nothing in common. There's no solution in common. All right, let's go to the third one. And what's the third one going to be? The third one says dependent. All right, this might be more difficult to understand, but it says dependent. Now, what is a dependent system? It's a system with an infinite number of solutions. So what's the first one say? Exactly one solution. The next one says no solutions. The third one says infinite number of solutions. Well, let me draw a picture of a line where they intersect everywhere. They have everything in common. So I put a line down, and then I put another line down. And for it to have all the points in common, they'd have to be intersecting everywhere. They're the same line, same exact line. All right, that covers out that section over there. Just to review what you did in Math 100. And it's really no different there. And we'll go through some examples. They're going to be short section though. Thank you.